Hello everyone, welcome back to TechWorld with Sahana. Today I'm back with another chapter in our Kubernetes Zero to Interview Hero series. Before we dive deeper into more advanced technical topics in Kubernetes, it is really important to understand the Kubernetes commands. Now, I know you might be thinking, why focus so much on commands? Can't we just memorize them and be done with? So, here's the thing, that's not how it really works. Think about it. In a Kubernetes interview, the interviewer is not going to ask you, can you get the details of a pod? Or how do you describe a pod? Or how do you get pod logs? Kubernetes professionals aren't expecting you to recite the commands by memory. And even in your day to day, the challenge isn't knowing about the commands. The real challenge is to know which command to use when the issue comes. Now, if you know the Kubernetes commands output, it is really easy and quick to find out which command to use for what type of issue. And you do not have to go through 10-20 commands just to find that one right command. Now, I know you might be thinking that I am new to DevOps, or I am just switching to DevOps, or I do not have Kubernetes installed in my system. How do I know what the output looks like? So here's what we are going to do today. We are not only going to look at the commands, we are also going to see what the output looks like and also try to understand in what type of issue we will use these commands. So enough talking, let's get started. So first let's go through some basic commands like version, cluster and node related. So the first one we have is kubectl version. So this kubectl version command shows both client and server versions of Kubernetes. The client version is your local kubectl tool, while the server version represents the Kubernetes API server that your cluster is running on. So we use this command to verify version compatibility between your kubectl client and Kubernetes cluster. It's especially useful before upgrading clusters or troubleshooting version specific issues. The next command that we have is kubectl cluster info. So the kubectl cluster info command displays the endpoint of the Kubernetes control plane and other key services running in the cluster. It tells you where the cluster is accessible and gives you an overview of the core components like DNS. We use this command to quickly verify the cluster is up and running and to check the URLs for essential cluster services. It's useful for troubleshooting cluster access issues or confirming cluster health after deployment. The next command that we have is kubectl get nodes -o white. So this command lists all nodes in the Kubernetes cluster and shows detailed information including the status of each node. It also shows the roles like control plane or worker node and the age of the node and also the Kubernetes version it is running on, as well as internal and external IPs, OS image, kernel version and container runtime. The -o white flag, this provides an extended view beyond the default output. And this command is used to verify the status and roles of a node, check cluster distribution, and troubleshoot node specific issues. It's particularly helpful when you want to see which nodes are ready, what OS they are on, and their network information. Now we will check out commands related to pods. The first command that we have is kubectl get pods. This command lists all the pods in the current namespace. The name column shows the name of each pod. The ready column represents the readiness status of the pod, showing how many containers are ready versus the total number of container it has. For example, 1 by 1 means the single container is ready. The status column indicates the current state of the pod, such as running, pending, terminating. And the restart column tells you how many times the pod has been restarted since it was created, which is useful to spot unstable crashing pods. The age column shows how long the pod has been running since its creation. Together, these columns give a snapshot of each pod health, readiness, and life cycle. We use this command when we want a quick overview of all the pods running in a namespace. For example, if a pod fails to start or stop unexpectedly, this command helps identify which pods are affected and how long they have been running. It's also helpful to quickly see if the pods are restarting repeatedly, which could indicate the configuration issues, resource constraints, or image problems. Especially, this is the first command you run when you are checking the state of your pod after deployment or during troubleshooting. The next command that we have is kubectl get pods -o wait command. This command shows all pods in a current namespace with additional details compared to the standard kubectl get pods. It includes all the usual columns like name, ready, status, restart, and age. But it also shows the IP address of each pod, the node it is running on, and the nominated node if the pod scheduled to move, and the readiness gates if any special readiness conditions are set. For example, the IP column tells you the pod's network address, the node column shows which worker or control plane the pod is running on, and the nominated node column is relevant during rescheduling. This wider view helps us understand the pod's placement, networking, and readiness in detail. We use this command when we want a comprehensive view of all the pods in a namespace. For instance, if a pod is not starting or showing pending, then checking its IP and node helps identify networking or scheduling issues. If a pod is crashing with crash loop backoff or terminating for any other reason, seeing the node and the readiness gate can help troubleshoot the cause. Essentially, this is a command you run when you need not just the pod status but also where it's running, its IP, the system level details, which is extremely useful for debugging, deployments, or verifying the cluster distribution. Okay, the next command we have is the kubectl get pods -l label and then its value. This command lists all pods that matches a specific label selector in the current namespace. In this example, the label we have taken is app equals backend. This filters the pods related to the backend application, and all other columns like name, ready, status, restart, age are that remains the same that we just checked previously. We use this command when we want to focus on a specific set of pods instead of listing all pods in a namespace. For example, if you want to check only the backend pod after a new deployment, this command helps you see which pods are running, crashing, or still pending. It's also useful for debugging, monitoring, or scaling a specific part of your application without being overwhelmed by unrelated pods in the namespace. Okay, so the next command we have is kubectl get pod and then the pod name. This command shows information about a single pod only, especially by its name. Then again, we have the same columns like name, ready, status, restart, and age. We use this command when we want to check the status of a specific pod. For example, after deploying a critical service or when a particular pod is failing, if the pod is in crash loop backoff or pending, this command helps you quickly identify its readiness, restart history, and age. It's particularly useful for troubleshooting a single pod without having to shift through all pods in a namespace. Okay, and the next command we have is kubectl describe pod and then the pod name. This command provides a detailed, in-depth view of a single pod. It includes metadata such as pod's name, namespace, node it's running on, labels, and annotation, as well as its current status and the IP address. Under containers, it shows each container's image, port, state, last state, exit code, restart count, and readiness. The condition section reports the pod's lifecycle checks, like whether it's initiated, ready, or scheduled. Finally, we have this event section. This provides a chronological log of significant occurrence, such as the container restarts, backup events, and this command gives a complete picture of a pod configuration, state, and runtime behavior. We use this command when we need a deep inspection of a pod. For example, if a pod is failing or not behaving as expected, it helps us identify why a container is crashing by showing exit codes, last state, and restart history. This is your go-to command for troubleshooting specific pod issues, understanding container states, and reviewing events that affected the pod's lifecycle. Okay, the next command we have is kubectl logs and then the pod name. This command retrieves the standard output and standard error logs from the specified pod's container. By default, it shows logs from the first container in the pod, but logs from other containers can also be accessed using -c container name. And this is what its output looks like for this command. We use these commands when we need to investigate why a pod is failing, restarting, or behaving unexpectedly. For instance, if a pod is crashing, the log can reveal application error, configuration issues, or connection failures. Okay, the next command that we have is kubectl execute -it and then the pod name with bin bash. Now, this command actually allows you to open an interactive shell session inside the running pod's container. The -it flag makes a session interactive and allocate a pseudo terminal so you can run commands like ls, cat, or any other shell commands inside the container. This gives direct access to the container's file system, processes, and configurations. In this example, you can see I have listed the application files and also inspected the configurations to check database connection details. And we can use this command when we need access to the container for debugging, inspecting files, or running commands that can't be observed through the logs alone. Okay, the next command that we have is kubectl delete pod and then the pod name. This command deletes a specific pod from the Kubernetes cluster. When you run this command, Kubernetes removes the pod and its containers. If the pod is a part of a deployment, replica set, or stateful set, the controller will automatically create a new pod to maintain the desired number of replicas. Deleting a pod is useful for forcing restart, applying configuration changes, or removing faulty pods that cannot recover. We use this command when we need to manually remove a pod. For example, if it's stuck in terminating state or an error state that cannot self-heal, then we can use this command. Also, deleting a pod forces Kubernetes to create it again with the latest configuration or image. Essentially, this command is a controlled way to restart pods, clean up resources, or recover the pod level failures. Okay, now we are moving with commands related to deployments. The first command we have is kubectl create deployment, name, and then the image details we are using. This commands create a new deployment in the Kubernetes cluster. This name defines the deployment's name. Here we are using my app, and the image specifies the container image. Here we are using Nginx latest version that the pod will run on. By default, the deployment will create a replica set with one replica unless we specify like this in the command. So this is what the command would look like. We will use replicas equals 3 or any other number of replicas you want. This command is used to quickly launch an application in Kubernetes with minimal configuration. For example, if you want to deploy a web server, database client, or any containerized service, you can use this command to create managed deployment that automatically handles scaling, update, and pod restarts in case of failures. The next command that we have is kubectl get deployment command. This command lists all the deployments in the current Kubernetes namespace. It shows the name of each deployment, how many replicas are ready, and how many are up to date, how many are currently available, and the deployment's age since its creation. We use this command to monitor deployments at one glance. It's handy for checking rollout progress, verifying scaling changes, or troubleshooting when some replicas are not ready or available. The next command that we have is kubectl describe deployment and then the deployment name. This command provides a similar detailed view of a specific deployment. It displays metadata like name, namespace labels, the current replica counts, update strategy, pod template details like containers, images, ports, environment variables, conditions, and recent events. This command is useful for in-depth troubleshooting and understanding how the deployment is configured and behaving. We use this command when we need a deep inspection of a deployment. For example, if a rollout is stuck, replicas are not becoming available, or scaling update are not reflecting. It helps pinpoint issues by exposing rollout conditions, strategy details, and event history, making it the go-to command for troubleshooting deployment rollouts, replica health, and configuration details. Okay, so the next command that we have is kubectl scale deployment and then the name of the deployment and the replica count. This command adjusts the number of pod replicas for a deployment. Kubernetes will automatically create or remove pods to match the specified replica count, ensuring the desired state is maintained. This command is used to quickly scale up and down. For example, increasing replicas during high traffic or reducing them during low usage. So even if you have a YAML with the replica count, which can be more or less than the ones we will use in the command, using kubectl scale will temporarily override the value in the cluster to the specified number of replicas that we are using in the command. Okay, so the next command that we have is kubectl rollout restart deployment and then the name of the deployment. This command triggers a rolling restart of all the pods in a deployment without changing the configuration or image. Kubernetes will terminate the existing pod and create them one by one according to the deployment strategy, ensuring minimal downtime. This command is useful when you want to refresh or restart pod, to pick up updated config maps, secrets, or environment changes, or to resolve issues without redeploying the entire application. Okay, so the next command that we have is kubectl rollout status deployment and then the deployment name. This command displays the current rollout status of a deployment. It shows whether the deployment has successfully updated all the replicas according to the desired application, or if there's any pod still pending, unavailable, or failing. We use this command to monitor and verify the deployment updates. For example, after performing a kubectl rollout restart or updating the image, this command ensures that all the pods are successfully updated and available before considering the rollout complete. Okay, so the next command that we have is kubectl create deployment, the deployment name, and the image details, and then we are using a parameter -o YAML. This -o YAML flag with kubectl create deployment command, this outputs the deployment manifest in the YAML format and also creates the deployment. This allows you to review or modify or save the manifest for later use. This -o YAML flag is used when you don't have a YAML and want to see the manifest that Kubernetes created with your command from the parameters you passed. The next command we have is the same command, but we are adding one extra parameter, that is dry run client. This flag generates the deployment manifest locally without creating the deployment. It allows you to preview and validate what Kubernetes would create, ensuring the manifest is correct before applying it. We use this command when we want to test or generate the deployment YAML safely without creating the deployment itself. Okay, so the next command that we have is again the same command with dry run client with additional parameter, which is the redirection signed and then a YAML name. So what this command does, it generates the deployment manifest without creating it in the cluster and saving it in the file named my app YAML using this redirection sign. Okay, so you now have a YAML file that can be reviewed, modified, and later applied to the cluster. We use this command to create a declarative manifest safely. It's useful when you want to version control your Kubernetes resource, make edits before deployment, or prepare manifests for teams without affecting the cluster. Next, we are moving with services commands. The kubectl get service. This command lists all services in the current namespace. It shows the name, type, cluster IP, external IP, ports, and age. This command helps you quickly see what services are running and how they are exposed. We use this command to monitor and verify services availability. For example, after creating or updating a service, you want to check if it has an external IP, external endpoint, or node port assigned and confirm the ports are correctly mapped. The next command that we have is kubectl describe service and then the service name. This command provides a detailed view of a specific service. It includes metadata like name, namespace, label, annotations, and the selector used to target the pod. You can also see the service types like cluster IP, node port, load balancer, assigned IPs, ports, target ports, and the endpoint backing the service. And also you can see the event section, which shows the recent actions or changes related to the service. Use this command to inspect and troubleshoot a service. For example, if a service isn't routing traffic correctly, this command helps you verify that the selector matches the intended ports, the ports are correct, and also the endpoints are active. The next command that we have is kubectl expose pod name, and then the port, and then the port number. This command creates a service that exposes the specific pod on the given port. By default, it creates a cluster IP, allowing other pods within the cluster to communicate with it. So we use this command when we want to make a single pod accessible inside the cluster without creating a deployment or full service YAML manually. It's useful for testing quick exposure of a pod or connecting other services to standalone pod. Next command we have is the kubectl delete service and then the service name command. This command removes the specific service from the Kubernetes cluster. Deleting a service stops exposing the associated pods through that service, but it does not delete the pod themselves. We use this command when we want to clean up or remove unnecessary services. If a service is no longer needed, is misconfigured, or replaced by another service, deleting it ensures it no longer routes traffic or consumes cluster resources. That brings us to our last command. kubectl port forward pod name and then the local port and the remote port. This command forwards a local machine port to a port on a specific pod in the cluster. This allows you to access the pod's application directly from your local system without exposing it via a service or changing cluster networking. We use this command when we need a temporarily access to a pod for testing, debugging, or local deployment. For example, you can forward port 8080 on your machine to a port 80 on the pod running on a web server and access it via localhost. So that's all for today. We have gone through the commands from chapters 3, 4, and 5. If any of the terms we used feels unfamiliar, take a moment to review these chapters and see you in the next session.